All right, in this example, what we're going to do, we're going to look at finding measurements for the impedance triangle or the impedance phasor, however you want to look at it, and the voltage phasor triangle. What I've been given is R is 10 kiloohms, L is 100 millihenries, F is 20 kilohertz, and then we have E at 15 volts. Now, what we are asked to find is X sub L, theta, Z. So therefore, that takes care of our impedance. And then we're going to find V sub R, V sub L, and lastly, I. Okay? So just go in that order. I mean, if that's the way you're asked to find it in that order. I know that X sub L is 2 pi FL. Hopefully you've been doing a couple of these and you're getting comfortable. And once again, you've got to consider your prefixes. And with L and F in the X sub L formula, it's much simpler to move the decimal points than it is to enter the scientific or the engineering notation. Excuse me. So X sub L is 2 pi. Frequency is 20K. Come on now, we've heard enough about K. We know that's 1,000. All right. So try to make that connection. 100 millihenries. Well, milli, when we have a whole number, we assume the decimal point's at the end. So we move it 3 to the left, which just gives us 0.1. So on my calculator, I go 2 times pi times 20,000 times 0.1, and I get 12,566. But that is ohms. I want to keep things consistent. So if R is in K ohms, I'm going to make X sub L in K ohms. So I've got to move that decimal 3 places to the left. And then R is 10. I'm going to round this to the 10th place. And again, it all depends on, what decimal place you're asked to round to. But normally, if one's a whole number, they're probably going to round the other one to the 10th place, just normally. So 10th place is 5. I know some of us have rounding issues. So I look to the right. Since this is 5 or larger, I add 1 to the 5 to make it 12.6. Okay, so if I look at, where I am, I've got this triangle, okay? I've got my impedance triangle, and I don't know theta, I don't know Z, I know R is 10K ohms, and now I know X sub L is 12.6 K ohms. So I can find theta by using tangent, opposite over adjacent, and as I've mentioned before, since they're both K ohms, we don't need to use our prefixes. So tangent of theta is 1.26. And since we are finding theta, we do tangent inverse. So 1.26 inverse tangent. And I get 51.6 degrees. All right, so I found my angle. And I do this, I fill in my triangle just to keep track of where I am. Because it's, it's difficult sometimes. So, I'm going through, I marked off X sub L, marked off theta, Z is next. Pythagorean Theorem, highly recommend that one. So it's the square root of R squared plus X sub L squared. Since everything's K ohms, we can just use the numbers without the prefixes, knowing that when we're done, our answer will automatically be in K ohms. So I get the square root of 258.76. Take the square root of that, and I get 16.1. And again, that's K ohms. So I've moved through. I've covered my impedance triangle. Gotten through about half of what I need to do. So next I need to find V sub R, V sub L, which is the, and I, but I will be last. But that's the voltage. Okay, so my voltage phasor in my RL circuit. We have E, which we know is 15 volts. I don't know V sub R. I don't know V sub L. But I pull theta from the impedance triangle because it is the same angle because it's in the same circuit. So I'm going to find V sub R. Okay, so I know the angle, I know the hypotenuse. V sub R is the adjacent side, therefore I do cosine. And cosine is V sub R over E. So cosine of 51.6 is V sub R over 15. And here's where you can cross multiply here or multiply both sides by 15, you know, whatever you prefer. So V sub R is 15 times the cosine of 51.6. So depending upon your calculator, you know, if you have a calculator where you can see everything as you type it in, just type in 15 cosine 51.6, it equals. I've got a TI-30X here, TI-36. I've got to kind of do it backwards. I've got to do 51.6 cosine, then times 15. And I get 9.3. So V sub R is 9.3 volts. To find V sub L, I'm going to use Pythagorean Theorem, but don't forget, since we know the hypotenuse, we've got to subtract to find V sub L. Okay? So it's getting a little blurry there. Come on now, focus for me, focus for me. So V sub L is going to be the square root of 15 squared minus 9.3 squared. So I get 138.51. Take the square root of that, and I get roughly approximately 11.8 volts. So I found V sub R, V sub L, checked myself because E should be the largest, and it is. So if you messed up and added instead of subtracted in the Pythagorean Theorem, you're going to get a bigger number, which can't happen. Okay, hypotenuse got to be the biggest side. Lastly, we find I, and I is E over Z. Well, E, you know, we're taking measurements from two different triangles. One's impedance, one's voltage, so we have to use the prefixes if we have one. So E is 15, Z is 16.1 kilo ohms. So I'm going to make that 16,100. And then we divide 15 divided by 16,100. And I get 0.00093. Okay, so 0.00093. And depending upon, you know, how they request your answer, if they want it in milliamps, then you move the decimal 3 to the right to get 0.932. If we want to go to micro, we go 3 more. So everything in engineering notation is multiples of 3. So as I go from my decimal point, And if I'm, since this number is smaller than 1, it's going to be either milli, micro, nano, pico, etc. And I just go in groups of 3s. So this would be 0.932 milliamps. They may allow you to just leave it in amps, which, would be 0.000932, or however they ask you to round it. Or if they ask for micro, again, you go to 3 more to make it 932 microamps. Okay. I believe most of the time they do milliamps. Okay, so that was, let me let it focus, the 932 microamps. Okay. So that's an example of, doing all measurements in both types of voltage and impedance, both types of phasors. They're not easy by any stretch of the imagination, but they're not impossible. Just take your time. The problem is, if you miss one thing along the way, everything else is wrong. Okay, so that's where the issues come into. So, if you miss something on your homework or on the review for a test or something, kind of just go back and and see where you may have messed up. It's not always easy to tell, but oftentimes, if you review it, you might be able to. So that's it for this one. We will stop here.